Hello viewers, in this video we will see the solution to week 6 assignment 6 for the course Microprocessors and Interfacing. First question, the number of 16 cross 4 memories required to construct 1024 cross 8 memory. So they have given 16 cross 4 memory, simply divide 1024 by 16, we will get 64. So 64 memory is required for 1024 cross 4. So we require for 1024 for cross 8. So additional 64 memories are required. So total memories is 128. Option D. 64 plus 64 is 128. Option D. Next one. So here we have to read a word, single bus cycle. What is the address, location? Address or location is 6000 C. So we will see that one, sir. So for 6000 C, C is a even number. That means A naught will be equal to 0. So this is an even address. So and for even address, A naught is equal to 0. For word, so this is for single bus cycle and for word. So BHE should be high, bus high enable should be equal to 0. That should be equal to 0. So option A. Third one, if the starting address of 4K memory is 00100, then ending address, we need ending address. We'll see here. Third one. So come back, he will see here this part. 2 power 10 is nothing but 2 power 10 is nothing but 1024. So if you increase one bit, it doubles. So 2 power 11 is 2048. This is 2K. 2 power 12 is 4K. So 12 number of bits are required. So 12 number of bits. So here 12 number of bits is all ones. 12 ones are 1 means in hexadecimal that will be 3F. In hexadecimal it is equal to 3F. H stands for hexadecimal. So which is equivalent to 4K. Now simply add the starting address 0010 to this capacity of the RAM. You will get 010FF ending address. Or you can subtract this ending address with the starting address. You will have to get 4F. You have to get 4F as the answer. Option A. Fourth one, so 8K RAM. Now A13 is bar is there. A13 is 0. A19 is 0. So fourth one. So what I am trying to do, come again here. See here. This is 8K. So 8K means 2 power 10 is 1K, 2 power 11 is 2K, 2 power 12 is 4K, 2 power 13 is 8K. So 2 power 13 is 13 address lines are required. So it is identified as or notated as, we can denote it as address A0 to A12. So I mentioned here A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12. These are 13 address lines, all zeros, and then that is for starting address, and all ones for the ending address. So for all zeros, 000 will be there. For ending address, F triple F will be there. Okay. And coming to the select lines, the remaining 13, 14, 15, 16, 17, 18, 19 are select lines. So now they are given A13 is 0, A19 is 0. So see A13, A19 are 00. So remaining 14 to 18 are 11. So 19 0, 13 is 0. Then 14 to 18 are 1111. So if you write that one, then try to convert the binary into hexadecimal. So what we will get here is, so this becomes 7, this becomes C, 000. This is starting address. Ending address will be 7. This is D. triple F. So option C, option C is 7C000 7D triple F. 7C000 7D triple F, option C. We'll move on to the fifth question. So control word is FC. So we'll see that one. So this is the control word format for A255. So this is port C lower, port B, then mode of port B, port C upper, then port A. This is mode for port A. This is IO mode or BSR mode. So if you come here MSB bit, if this is 1 IO mode, if it is 0 BSR mode. So what is the given? So what they given? FC is given. So simply write 1111 is F and 1100 is C. So now the question is related only for port A. So 1 means input port, 0 means output port. So we'll come to this one. Port A is 1. 1 means input port. So 11 means mode 2. 00 means mode 1. 01 is mode 2. Sorry, 01 is mode 1. Then 11 is mode 2. So 10. 1 second, we'll check. So port A will be programmed as input port, option. This is input port mode 2. So port A input port mode 2. Input port port 2. Input port mode 2. Sixth one, if the control load register for A255 is loaded with FF. So sixth one. Again A0, A1, A2, A3, A4, A5, A6, A7. What they have given? FF they have given. Okay, now coming to this one. Now we will consider only these two parts. A0, A1, 00 means port A, 01 means port B, 10 is port C, 11 is control word register address. Okay, so they have given, this is the given FF they have given, Where is that one? FF is given. So FF is given. So if you write for the remaining, if you complete it, all ones. So the address of port A is FC. FC is option A. Seventh one, similar one. So now this is we have A7, A6, A5, 0, 0, 0. A7. So A0, A1, A2, A3, A4, A5, A6, A7. A7 is 0, A6 is 0, A5 is 0, remaining is 1, 1, 1. So again 0, 0 means port A, 01 is port B, 10 is port C, 11 is control register. Okay, so now what they have given is A7, A6, A5 is 0, 0, 0, 0. A4, A3, A2 is 1, 1, 1. So A4, A3, A2 is 1, 1, 1. So all these are same, except this one. So therefore, now they are asking for control word register address. This is 0, 0001 is 1, 4 1s is 1, 4 1 is F, So the answer is 1F. Answer is option A, 1F. Eighth one, the time taken to execute move CX, 4F. So you can see eighth one. So this instruction move CX, any 16-bit number, it requires 4 clock cycles or 4 T states. So 1 T state is nothing but 1 clock cycle, that is equal to 1 by F. F is equal to 10 megahertz. So that is equal to 0.1 microseconds. So 4 into T is 0.1, 0.4 microseconds. Option B.